Okay, here is a test question that I made, and I'm trying a new pen. Let's see how that goes. Just in case you care, because sometimes you care about those things. It may not work. Okay. So I have a house that uses, this is the amount of power the house uses. It's 1453 watts. I just made that up. The average power of a house really fluctuates. It's actually proportional to the price of electricity in that state. Here in Louisiana, electricity is pretty cheap. It's like 11 cents a kilowatt hour. So actually, that would have been a good question here too, but I didn't ask that. So over a course of a single day, what's the power? And you want to power with solar panels. The intensity of the sunlight is I equals 1360 watts per square meter. I do like this pen. I'm going to go ahead and tell you that right now. Okay. And the solar panel has an efficiency of 0.25 or 25%. The average angle between the sunlight and the solar panel is 35 degrees. So not this one. Here is my solar panel, like that, and then here, let's say the sun's straight down like that, and then so this angle is 35 degrees. Okay, that's usually the way we measure it anyway. So what size solar panels do you need to power your house? So this is the power, the intensity. The power is going to be the power that you get is going to be the efficiency times intensity times the area, which is, let's say that's efficiency times the intensity times, let's say it's a square solar panel. I should have said that, but if whatever you did is fine. So I can say L squared. And I want to solve for L. So I know the power is 1453 watts equals 0.25 times 1360 watts. This is the solar intensity of the sun on the surface of the earth. Watts per square meter times L squared. So let's solve for L squared. L squared is going to be equal to 1453 divided by 0.25 times 1360. I left off the units, but let's go ahead and then I can take the square root of both sides, and I'll get my length. And that's that. Okay. See if this turns on. Yep. Okay, so I'm going to drop that. It's going to be 1453 divided by 0.25 divided by 1360. And then take the square root. So I get 2.07 meters. So that's like about a 2 by 2 meter solar panel. So we're thinking if you want to convert that to imperial units, 6 feet by 6 feet about. That would do it. But that wouldn't do it, just so you know. Okay. I didn't ask about this in here, but here's your solar panel. That's a good size solar panel. But this assumes that the sun is at the same angle and the same intensity over the day. This answer would be fine for me. But really, the intensity of the sun changes, the angle of the sun changes, and then it goes to zero, right? We have zero intensity at night. So if you had to do this over the whole day, if you want to run the house off the solar panels the whole day, you'd probably need quite a bit larger solar panel. And this maximum angle depends on the time of year or two, so there's a whole bunch of things going on about the energy you get from a solar panel. But that's the thing I was looking for. Not too hard of a problem. Now then, the question would be, if you do the price, let's say the cost is 11 cents, 0.11 US dollars per kilowatt hour, then how much money do you save? I maybe leave that for you, and you can do that later. But that's another problem.